Okay. So
Let's hang on. Let's just do the last two.
okay. So for 5x power 7 times 2x squared, will that just be 15x to the power of 9?
Sorry, E and F, top to up the top.
That's what I was thinking was. Will that just be 2a to the power of 8? Oh no, 2a or even, yeah, just 2a to the power of 8.
And F.
Will that be 27x to the power of 6 divided by x to the power of 4, which will be 27x to the power of 2.
Yeah. Let's just expand in brackets. Fine, I think. Let me take a look. How would you do C down the bottom?
Is that 3c? Yeah.
Yeah.
Will you just do will you just separate and do 6x to the power of 4 over 2x cubed and
Yeah.
then etc.
And so what would you get then?
So if you separate the first one, for example, you get 3x, just 3x for the first bit,
Mm-hmm.
and then six. Oh no, will it just be? Oh no, will it just be 6? Yeah.
Mm-hmm.
Um, and then so that's going to be 6 minus 16x to the power of 10.
Yeah.
And then that'll give um, minus 8x to the power of 7.
X to the 7. That's it. And I don't have the answer for that one. Okay. These are fine. They're going to be fine. That's going to be fine. What would be 6A?
Well, that should be to the power of 4. Or no,
You can use a calculator.
to the power of 5.
That's it.
Yeah.
Those fine. Similar. What is 8A?
So, will that just be 5x to the power of no, just 5x.
Yeah. Okay, so that's index laws. Expanding brackets. I think you're good. So it's expanding. How could you do question 6?
So okay. Could you just put it into your calculator
Yep.
and then I think the answer will be that A is 3 and then B is 4.
So A equals 3, B equals 4. And so it was 2x minus 7 and then 3x plus 4. So, yep, that's good. That's fine. Volume, that's fine. I'm happy. Let's see. That's fine. Expanding brackets. Factorizing. I think can be fine for those. Largest calculator.
Yeah.
So these negative and fractional indices. Let's see. What is 7b?
So will that be x cubed times times 64 64x squared.
7b?
Oh, sorry, my bad. So will that just be so first bit, so I need to start off by doing 3 over 2 to the power of 8, don't I?
Yeah.
I got like a weird number. I got like 6,561 over 256.
Oh, what was it? Sorry, 2000.
Oh, no, 256.
That's okay.
Okay, and then x x and then to the power of minus 2.
Mm-hmm.
And then times that by x.
Yeah.
And will I just get 6,566? Will I just get x to the power of minus 1 instead of minus 2?
Yeah. 256. And another way of writing that is just putting the x on the bottom with a plus 1. And okay, I don't have to answer that. That one is very similar. This might be worth looking at. Okay, how about these two?
Okay. So do I need to sub that in and put in a ninth x squared to the power of a half?
Yeah.
And then that will be an 18th to the power of x.
Hold on. Put into your calculator 1 over 9 to the power of a half.
It's a third.
Yeah.
Yeah. So I thought, is the answer just a third x?
Yes. Power of a half is the same as square root. And try B.
And then so 2 and then a ninth x squared to the power of -1. And then so that'll be 2 times 9x 9x to the power of -2, and then it'll end up. Well, the answer end up being 18x to the power of -2.
Uh,
18y. Sorry.
Say it again, sorry.
Will the answer end up being 18y to the power of -2?
Be 18. You're thinking of 18x to the -2, is it?
Yeah.
So it'll be x to the -2. Put into calculator. 2 times 1 over 9.
Which is 2/9.
Yeah. Why were you thinking that would be 18? Because of the -1?
Yeah.
Because of Bidmus, to the power of the power is connected only to the x and not. Oh, hold on. Sorry, I'm an idiot. 18. Because it's in a bracket. That comes. Yeah, so they're both to the power of -1. Sorry. Don't mind me. That's. I think you'll be fine. Surds. You said index, not surds. Am I right?
Yeah, but surds is good to do as well, I guess. I don't know.
It's not. Okay, let's try this one.
Okay. So I need to make 3. So is that going to be 243 times 3 to the half? First of all.
Yeah.
And then I need to find what divides. So then I need to. Oh no. 2, 4, 3, 9. And then I need to divide 243 by 81 to get 3, I think. Or.
Okay.
And then. So that'll be 3. And then 3 to the 5 is. Okay. Equals to 3a. So I think the answer will just be that a is 5.5.
Yeah.
Okay.
Is 5.5. 5.5. And let me just try something here. Option calc solve n 2 4 3 shift root 3 shift equals 3 to the power of x for sake of convenience equals 11 over 2. Yep.
Okay.
Boom. I'm sure they'll try to thwart us from doing that too often. So that's surds, the hardest one for surds. How would you do the top one?
So is that just where do I have to times the top fraction and bottom fraction by 2 plus root 3?
In theory, yes, and in practice, just put it into your calculator and it should auto rationalize for you.
Oh, okay.
I'll just check. 2 over 2 minus shift root 3, press equals, and auto rationalizes.
Okay.
Same with expanding surd brackets.
Yeah.
Press back. We can do yeah. Let's do this one. Hang on, I just want to no. Yeah, let's do this one.
Okay. So does that mean that would just be root 14 minus 2 times x
Right.
equals to 5? And then do I have to do 5 divided by root 14 minus 2?
Yeah. And you could just put that in your calculator and auto rationalize.
And then there'll be x is equals to 2 plus root 14 over 2.
Easy peasy, easy peasy. Okay, how about this one?
Okay, so so okay, so do I need to do so first bit, make x root 12 different.
Nope. I've taught you nothing. Type the whole thing into your calculator.
Oh, with the right, yeah.
Just give it a go.
Okay. So I got x as 6.928.
Okay, so that means it thwarted us.
Yeah.
And so we have to now, so we do have to do it by hand. Okay, but we should always try, see if we can.
Yep.
Okay, so what do we do first?
Maybe change root 3 to a half to 3 to the power of a half.
All right, what would you have to do?
Change x root 12 to the power of something as well.
Power of a half.
Yeah, I guess. Yeah, yeah.
Then what?
Um, Wait, so I was trying to confirm. So when it's x to the power of x root 12, does that mean x times root 12?
Yeah.
Okay. So does that mean that it will become 8 plus 12x to the power of a half on the left side?
No, because of bidmas, power of a half is connected only to the 12.
Right, okay. So
Tell me if you're stuck.
um, so I got 8 plus x 12 to the power of a half equals to 8x over 3 to the power of a half. So do I need to now take the 3 to the power of a half to the other side and times expand the brackets?
Yeah. Put into your calculator root 12.
2 root 3.
So I had a hunch about that. But
So,
okay, doesn't really matter, I suppose. Okay,
so,
go on.
so does that mean that x is 2? Oh no. Does that mean that x to the root 12 is just 8 plus x to the 2 root 3?
Well, my guess is b will be 3. You'll have root 3, but we can't really do that. So go on, multiply both sides by root 3. What do you get? Or by 3.5 or whatever.
So you get bad numbers.
So you have basically root 3 times 8 plus x, let's say 2, let's just say x root 12 equals 8x.
Yeah.
What is, so they want it in the form of a square root, so we don't, so we'll keep it as a square root. What is root 3 times 8?
Root 3 times 8 equals to 8 root 3.
And that's the kind of form that they're looking for it in, so we'll just keep it like that.
Yeah.
This one.
And then plus 6x
How did you get? Yeah, okay, 6x, great.
equals to 8x. And then 8 root 3 equals to 2x.
Mm-hmm.
And then is x equals to 4 root 3.
That's it. So what's A, what's B?
A is 4, B is 3.
Yeah. So if they want it as in an exact form, just keep it in the exact form. Sometimes it's necessary to change it to the power of a half, but this wasn't one of those times.
Yeah.
Yeah. And in fact, we could now put into our calculator. Let me try something. Oh, I'm an idiot. Press answer, press equals. Nah, it wouldn't have worked. Okay. 6.928. And I put into my calculator 4 root 3. SD 6.928. I get the same number.
Yeah.
And so I know we're correct. Any questions there?
No.
So you asked to go through Surd stuff. Sorry, index laws. So that's chapter 1. We did all of chapter 1, half an hour. I hope you're happy.
Mm-hmm.
Possible exam question. Proof. Easy. Did it. We did it, I think. Okay. Let me just see these. Let me see something. It's fine. Did it. It's okay. Did. Yeah. Okay, this is what we needed to do. So methods of proof. Proof by exhaustion. Do you know what that means?
No.
Just trying all possibilities. So yeah, you just exhaust all possibilities. Let's see. Prove that all square numbers. That's not really a proof by exhaustion. We'll start with proof by exhaustion. So it doesn't seem to come off very much.
Sorry, what's this topic called? Sorry.
So this is methods of proof.
Okay, choose. Yeah.
Yes, this is it. Okay, how can we do this?
So. So we have to just take all numbers in between that bracket and then sub them into n squared plus 2 and then show that it's not divisible by 4. Or
Yeah. Do you know a quick way to do it?
I'm guessing just do the first number and the last number or something like that.
No. They'll want to see what they are. Menu table 7. I'll just delete what was there. What would you put in?
2. Is it 2?
It would be. I'll use x. X squared plus 2.
All right. Yeah.
Let's see. So we need to do set F5. Our settings. What's our start? What's our end? What's our step?
So start 2, end 7, step 1.
Yeah.
So how did you get to that? What did you press on the calculator? Sorry.
So I went up 2 onto it and pressed F5 for set. Maybe it's like settings or something.
Is that for the table thing?
Yeah.
Okay.
Tell me when you have that.
All right. Yeah.
And I believe you press table. F6 when you have it all set up.
Yeah. So, sorry, is it table then F5 or F6 or F?
Did you do your settings?
No. I just got to the table bit.
So this bit.
Yeah.
So just put in. Did you put in x squared plus 2?
No. So x squared plus 2. Yeah.
Then go back up to it and do settings. Set.
Yeah.
And choose 271.
And then yeah.
And then come back out and choose table.
Yeah, I got like all the numbers and stuff. I thought.
Okay, and so we have to put them in. And so we have 2 squared plus 2, 3 squared plus 2, 4 squared plus 2, 5 squared plus 2, 6 squared plus 2, 7 squared plus 2. Okay, so I think it's what? 11, 18, 27, 38, and 51. And yeah, none are divisible by 4. Or evenly divisible by 4. Wait, 2 squared plus 2. That's 6. That's 6. Yeah. Yes. And so you just exhausted all possibilities there.
Yeah.
Any questions about that?
No.
Okay, and it's just it's good to use the table for. It says proof by exhaustion. Okay, let me now go back. Next one. Counter example. So find some example that invalidates it.
Is that for A?
Actually, A is just proving it in general. Any idea how to do
that? Is this A or B? Sorry.
A.
Okay, so. So use of X and Y. So would you just get 2 random numbers and then just prove that they were that positive, and then just prove that they're greater than 2 or something?
Nope. All positive values.
For all positive values, do we have to use the table thing again?
You can't put all positive numbers in. Try adding the fractions algebraically.
So they need to have the same denominator, don't they?
Mm-hmm.
So do I have to times the left fraction by X and the right fraction by Y?
Mm-hmm.
And so that will give X squared over XY plus Y squared over XY.
Mm-hmm. XY. You're saying that's greater than or equal to 2. What could you do next?
do x squared plus y squared is greater or equals to 2? Or, I don't know.
X squared plus y squared.
Oh, is it because this is the minimum?
I'd get rid of the denominator.
Yeah. So I'll now just be x plus y.
Just no. Multiply through by the denominator. You can't simplify that. You would just go back to being the original question. So if you multiply both sides by xy.
So it would just be xy at the bottom, and then xy times x squared plus y squared.
So if you multiply by a denominator, it just goes away. Basically, the xy's would cancel out.
Right. So, I need to make it greater or equal than 2xy.
Yeah. So essentially, you're just moving it to the other side by multiplying. Any idea what you do next?
So, would be I'm not really sure.
I think you'd make 0 the subject.
So x squared plus y squared minus 2xy.
Yeah, I'll put that in the middle. Plus y squared. Can we factorize that? I think it's... Is that the same as x squared? X minus y squared? Is that right? You get x squared minus 2 times x times y. Yep. And then, how do we prove that is that? Oh, yeah. What do you know about anything squared?
It's always going to be at least equals to 0.
Yeah. And I
So-
think we've kind of done it then.
How did you get to x minus y squared, sorry?
Factorize it.
So, okay.
So it's like x, 2 brackets, x minus y, x minus y.
Okay.
And then that can be written as something squared, which is always greater than or equal to 0. Let me see if they did something different. So you have the two things. Add the two of them together with denominator xy. Times by xy. Make it that. That's squared. 0. Yeah, same thing. Yeah. Okay. Any questions with that one?
No.
Let me see something. Proof. Oh, that's exhaustion. I'll do that in a second. Okay, how do we do this one?
Okay. Okay, so what I need to do? Um, 1/a is greater or equals to 2 minus a.
I would get rid of the fraction. That's the tricky bit.
I think I might have already got it.
Okay.
So I got to minus a squared plus 2a minus 1 as like a quadratic in like an inequality.
Right.
And so should I just put that into my calculator?
A squared minus 2a plus 1, is it?
No, I got minus a squared plus 2a minus 1.
So you just brought them to the other side.
Yep.
I like to keep the squared thing as plus, because then it's just more similar to what you're used to.
Yeah.
Okay, what's that in your calculator then?
It says they're all real numbers.
Did you use the quadratic solver, or you just the simple solver thing?
I used the inequality solver.
Oh, okay. What did it say?
It's
Sorry, go on.
it says just all real numbers.
Try putting it into the equals solver.
Okay. I got x is 1.
And what can you do with that?
Or even a is 1.
What can you do with that?
So you could sub that into the equation, and then if it's greater or equals to 0, then you know you're right. It's smaller or equals to 0.
I would use it to factorize.
Okay.
If a equals 1, then what's the factor?
Sorry, so do I now need to just put in 1 squared and then factorize that?
Just factorize a squared minus 2a plus 1.
So a minus is that going to be like a minus 1 squared minus 1 or something like
that? It's basically a minus 1, a minus 1.
Okay.
Or another way of writing it.
A minus 1 squared.
Yeah. And therefore it's proven.
Yeah.
So it's just write it as something squared. It's greater than or equal to 0. You'll make 0 the subject, make the other square bracket, and you've done it. Any questions there?
No.
So our usual stuff, because we're not trying to solve anything, we're just proving it. I think, let me go back. I think I overlooked type of question that we should. No, I pressed save. Oh well. I'm not going to do that yet. Okay, let's try this one.
Okay, so rise of x. So prove that. Oh, do I need to expand the brackets first for the left bit?
Yep.
And so that will be x squared plus 12x plus 36.
Mm-hmm.
And then do I just need to make it greater or equals to 0?
Yep.
And so that'll be x squared plus 10x plus 25 is greater or equals to 0.
Mm-hmm.
And so and then when I put into the inequality calculator, it just comes out with all real numbers.
So we know that's true because they told us it. We're trying to prove it.
Yeah. Oh, it would just be because there's a square number and there's only positive numbers. It can only minimum be greater.
It's not. What square number? What do you mean?
X squared, like.
Nope. Because it's plus 25. Factorize.
So, well, that should be x plus 5, x plus, yeah, well, that should be x plus 5, x plus 5.
Mm-hmm. Fully factorize?
And then I need to make it squared.
Yep. And now you've done it.
Yeah.
And last type. Counter example B. So there's some number you can find that violates that thing. 2 numbers in this case.
So, I'm not really sure.
Pick 2 numbers.
I'm not very positive, so do I need to pick 2 numbers which aren't positive?
Yeah.
So could that be like, when they're not positive, that means negative, is that like -2 or -3 or something like that?
So sub them in, see if that works.
Okay, so if I sub in, so if I say like x is equal to -2 and y is equals to -3,
Mm-hmm.
and then if I put in -2 over -3 plus -3 over -2, it's greater or equals to. and then it says it's greater or equals to it's not true and x and y both positive and not both positive.
No. So you just put it in your calculator. So it's like 2/3 plus 3/2, because the negatives cancel.
Yeah, I got a number which is more over 2.
Yes. So the way you would, we're trying to find a counterexample, so we're trying to get a number that's less than 2. How do you go about that? Any way you could end up with a number that isn't greater than 2?
No.
One negative number, one positive number. So this time you could try 2 and minus 3.
So if I say like x is equals to 2 and y is equals to minus 3.
Yeah.
But
So 2 over minus 3 plus minus 3/2. And that's obviously that's going to give us a negative number, whatever it is. And so x equals 2, y equals minus 3.
yeah.
So it's just any counterexample that violates it. So how about this?
Yeah. That gave me. Yeah.
Yeah. So I'll just give you some negative number. How about this one?
You cancel them for the photo, but I'm saying it's false. So would you have to first of all write out the equation and do like x plus 2 squared, or?
Nope. Just find any number that will violate.
In the square round. So if I just say 7.
So you could, yeah. Okay, so 7.
So if I just do 7 plus 2, which is equals to 9, and then do 9 squared equals to 81.
So if you add 2 to a number and square it, the result is always greater than the square of the number. So we got 81, which is bigger than 49. So that didn't violate it. Anything else? We could try it.
Could we try a negative number?
Sure.
So if you did like minus 3 plus 2 squared.
Okay.
And then that would give you 1 squared. Yeah, so if you did minus 3 plus 2 squared, which will give 1.
Mm-hmm.
Just do minus 3 squared on its own, that will give 9.
That doesn't really work, does it?
Yeah.
Let's take a look. Oh, minus 2. So if you make it 0, that's what will do it.
Okay.
X equals minus 2. So there are certain numbers that are special that work. A negative, like minus 1, a half, and making the thing 0. So just try different numbers until you find one that works. That's called proof by contradiction. Tricky stuff. So proof. How are you for that one?
I'll say I'm like sort of halfway there. I just need to improve on like factorizing and stuff like that. But I think I'm like halfway there.
No one's got that proof, to be honest. But that's the end of chapter 7 anyway. Yeah, and we could do whatever you want next time, or just chapter 8. Any questions for me about anything?
Are we able to do differentiation next time?
Yeah,
Okay.
do that. Anything else?
I think that's it.
Alright, well done, Andrey. You did great. I look forward to chatting again next week.
Okay, thank you. Bye.
Goodbye.